So let's get started with an overview of AWS RDS. RDS stands for Relational Database Service. And what it means is that it's a managed database service for database that use SQL as a query language. So SQL is a structured language to query a database. It's very well adapted and it's running on many engines. So it allows you to create databases, the RDS service in the cloud, and these databases will be managed by AWS, and you get a lot of benefits from it. So what types of database engine are managed by AWS? Well, the first one is PostgreSQL, then we have MySQL, MariaDB, Oracle, Microsoft SQL Server, IBM DB2, and Aurora, which is a proprietary database from AWS that we'll study in depth. So you have to remember the types of engines that are supported by Amazon RDS. So why would we use RDS versus deploying our own database service on top of, say, an EC2 instance, because this is possible? Well, RDS is a managed service, and as such, AWS provides a lot of services on top of just giving us a database. For example, the provisioning of the database is fully automated, and so is the underlying operating system patching. There is continuous backups being made, and you are able to restore to a specific timestamp. It's called point-in-time restore. You can also have monitoring dashboards to view the performance of your database. You can have read replicas, and we have a dedicated lecture on read replicas in this course to improve read performance. You can set up multi-AZ, and so we do have also sections on multi-AZ that will be helpful for disaster recovery. You have maintenance windows for the upgrades, and you have scaling capabilities, both vertical by increasing the instance type and horizontal by adding read replicas. Finally, the storage is backed by EBS, so this is something we already know. But the only thing we do not have is we cannot SSH into the instances, the RDS instances. So because this is a managed service, AWS provides us a service and we don't have access to the underlying EC2 instance. But this is not too bad because we get all these things that we would have to set up on our own if we wanted to deploy our own database engine on EC2. So here is one feature that can come up in the exam and is around RDS storage autoscaling. So the idea is that when you create an RDS database, you need to say how much storage you want. For example, you want 20 gigabytes of storage, but say you are using your database a lot and you're about to run out of free space, then with this feature enabled, the RDS storage autoscaling, RDS will detect that and will scale automatically the storage for you, so you don't have to do any kind of operations such as taking down your database to increase the storage. So the idea is that your application does a lot of read and writes to your RDS database, and then automatically with some threshold we'll see in a second, then the storage can auto-scale, and that is a feature of RDS. That is a very, very nice feature. So this all is meant to make you avoid the operation of scaling manually your database storage. For this, you need to set a maximum storage threshold, so a maximum limit for how much you want the storage to grow, because you don't want it to grow infinitely maybe. And you can automatically modify storage if the free storage is less than 10% of what has been allocated, and the low storage has been lasting for more than 5 minutes, and 6 hours have passed since the last modification. If that's the case, then the storage will auto-increase when you enable it. This is very helpful for applications that have an unpredictable workload, and this supports all database engines for RDS. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Going into the exam, it's going to be extremely important to understand the difference between RDS read replicas and multi-AZ and understand exactly the use cases for those. So this lecture is really dedicated to understanding read replicas and multi-AZ. So let's get started with the read replicas. Read replicas, as the name indicates, help you to scale your reads. So let's have an example. Here we have our application and we have an RDS database instance. And our application performs reads and writes to our database instance. But say we want to scale the reads because that main database instance cannot scale enough. It receives too many requests. Well, we can create up to 15 read replicas. And they can be within the same availability zone, cross availability zone, or cross region. So 3 different options, and they're very important to remember. So say we have another RDS instance read replica and another one. And what will happen is that there will be an asynchronous replication between the main RDS database instance and the 2 read replicas. Asynchronous, that means that the reads are eventually consistent. What that means is that, for example, if your application reads from the read replica before they had the chance to replicate the data, then you may get all
If you're looking to get started with files here, and I go to Documents and Vaults, my effective vault, you can see the welcome note graph view, but they're not really all that connected. I'm going to highlight a couple of phrases in here that I know I'm going to want to come back to. So I'm going to highlight personal operations, and I'm going to hit the left bracket twice, and that creates a wiki link. I'm going to do the same thing for productivity, personal knowledge management, and time management. There's the bullet journal method too. So I'm going to highlight personal operations, and I'm going to hit the left bracket twice, and that creates a wiki link. I'm going to do the same thing for productivity, personal knowledge management, expand into in the future. And so I'm going to go back to the scratch pad, and I'm going to do the same thing here for these nodes. And I'm going to use the command palette to get to it this time. Extract current selection. I'm going to look at this saying personal vault. So you can get and just open a note that way. I'm going to look for the marketing seminar note. And then this was a course that I took on marketing, a couple graph. This opens it in a and see. Oh, I do some other stuff with it to.
The first list is off as you kind of an image into Obsidian, it gets saved into this assets folder that I have, which is pretty helpful. Now note that you don't only have to embed images, you can also embed, I don't want to search through the entire Markdown course, I just want to search for this specific file. So this file, I'll go ahead and give a resources tag. So now I know that this file is not only part of a markdown course, but also is a file that I want to refer to in the future for how to write basic markdown syntax. So now instead of having to decide between two folders, I can just give it both tags and easily identify it. Tags actually have a subdirectory structure. I don't remember the exact professional
which is right here. It's going to show you a drop 4 plugins shown here to enable it. So now it's enabled. You can do some stuff with it, but we're just going to use it straight out of the box. So again, I'm going to select this text, those, hide the vault. This next one, launcher, like there's a lot of stuff here that we're just not going to get into, but yeah, hopefully this video was helpful at getting you at least a little more comfortable.
Hello everybody and welcome to advanced kind of functionality. And that's all well and good, but just know that that's not actually doing real work. And then you have a system first and then try to change your behavior to fit the working. Taking notes is easy. You take. Productivity ebbs and flows. Into after want to actually edit the note at all. I know that I need to get over this. I don't know if anybody else feels this way.
Hey everybody, and welcome back to another YouTube. Where did that go? Nice and neat, very simple to look at. Right? But the main thing you really want to focus on, first of all, is let's say that, actually, let me show you how to answer it to yourself, open it, and say, okay, I was kind of close, I wasn't, and then based on that, decide what you need to study further. Another great thing about Markdown, and I guess any Markdown, but Obsidian as well, is that you can write code, you can insert code blocks into it. So, you know, how do you define a struct? We can have that, indent this, and then have this nice little code block. You can specify what language you want in the code block by just doing 3 backticks, then the name of the language. Active, and that's a boolean. Their username, string, email, which is a string, sign in count, which is an unsigned 64-bit integer. Right, boom. And then, ta-da, it's quite nice. I don't know what that is indenting, but I'll do like this. You can do it based on the actual lecture. And as you can see, I wasn't really consistent with again the heteraz in my actual note. And the cool thing about Obsidian, Obsidian allows you to collapse your headers, so this makes it nice and easy. Now, additionally, I like to try and phrase my notes in the form of a question. So
the hardest part about folder as an Obsidian vault, and that means I can kind of use Obsidian as an IDE. It provides a better interface for me for interacting with that own words and created something new with it. One of the coolest features about Obsidian is it actually has slides built in. It uses Reveal.js, and you can create a simple presentation just by using these dashes, and then you just click here and then start.
I'm going to hit the bracket icon. So bracket, bracket, and now it's pulling up those 250 plus notes, and it's allowing me to make a link to one of them. So in this case, I could make a link to, let's say, note takers. Interesting. So that was the first one that came up. Note takers. Now, before we go any further, I just want to let you see a little bit about what's happening in this application called Obsidian. In the middle, we have our document, what we're calling a note. Now on the left, we have folders. They are holding all the notes. There are some other icons. Don't worry about that for now. On the right, we have a couple panes, but the one we're of linked light kit, because it's essentially, now let's see how links can help us think better. In this case, I'm going to go to Habits, Map of Content, MOC. I'll close this for now, and I'm going to click on the first link I see here, which is defining a habit. Defining a habit. So on this habits map of content, let me start with the definition. That's what I did here. And then as we're reading through this, you can do that on your own time. I want to see where it's taking me if I click on feedback loop. Okay, so now I've clicked on another note, and it's taking me right to feedback loop. The more you feed me, the more I feed you. We can read about feedback loops. Related at the bottom, habits carry a ton of hidden inertia. So I'm creating this almost choose your own adventure.
data. And this is why it's called eventually consistent asynchronous replication. And these replicas, they can be awesome for reading, for scaling reads, but they can also be promoted to their own database. So you can take one of these replicas and say, okay, I want it to be its own database now, and take writes. And so you promote it to its own database. It's completely out of the replication mechanism after that, but it lives and has its own lifecycle afterwards. So in case you want to use read replicas, the main application in orange in the top of the screen must update the connection string to leverage the list of all the read replicas you have in your RDS cluster. Okay, very nice. So let's talk about a classic use case for your read replica. So in this example, we have a production database and it is taking on normal load. So here we go. Our production database is having read and write to our main RDS database instance. And a new team comes in and say, we want to run some reporting and some analytics on top of your data. And so if you plug in that reporting application onto the main RDS database instance, then it's going to overload it and possibly slow down the production application. And you don't want that. So instead, what you do as a solutions architect is you create a read replica to run the new workload there. So you create a read replica. There is some asynchronous replication that happens between your main RDS database instance and your read replica. And then your reporting application can just do reads from your read replica and run the analytics there. The production application is completely unaffected in this case, and that's perfect. So remember, if you have a read replica, you need to ensure that it is only for select type of statements, and select is a SQL keyword. Select means read, and so you cannot use keywords such as insert, update, or delete, which change the database itself. Okay, read replicas is only for reads. So let's talk about the networking cost associated with RDS read replica. So in AWS, you should know that normally there is a cost when the data goes from one availability zone to another. But there are exceptions, and these exceptions are usually for managed services. So for RDS read replica, this is a managed service. If your read replica is within the same region, okay, different AZ, but same region, you're not paying that fee. So what this means is that if you have a RDS DB instance in US East 1A, and then a read replica in US East 1B, and there is a synchronous replication because this is a read replica, even though the traffic goes from one AZ to a different AZ, that replication traffic is going to be free because RDS is a managed service and they give you that traffic for free. But if you are using a cross-region replica, so you are in one region, US East 1, and you go to another region, EU West 1, for example, then your RDS DB instance and your replica will have replication that will go across regions, and this will incur a replication fee for your network. Finally, let's talk about RDS multi-AZ. And multi-AZ is mainly used for disaster recovery. So we have our application, and it performs reads and writes to our master database instance, which is in availability zone A. And what we're going to have is a synchronous replication to a standby instance in AZB, and it will replicate every single change in the master synchronously. So that means that when your application writes to the master, that change needs to also be replicated to the standby to be accepted. And so what we get out of it is one DNS name. So your application talks to one DNS name, and in case there is a problem with the master, there will be an automatic failover to the standby database thanks to that one DNS name. So thanks to this, we increase the availability. This is why it's called multi-AZ. And there will be failover in case we lose an entire AZ, or we lose the network, or there is an instance or storage failure for the master database, in which case, obviously, the standby database will become the new master. You don't need to do any manual intervention in your apps. As long as it tries to keep on connecting to your database, automatically at some point it will fail over to the standby that will be promoted as the master, and you'll be good. and it's not used for scaling. So as you can see here, the standby database is just for standby. No one can read to it, no one can write to it. It's just here as a failover in case anything goes on with your master database. So quick question is there a possibility to have the read replicas being set up as multi-AZ for disaster recovery? And the answer is yes. You can set up your read replicas as multi-AZ if you wanted to. And that is a common exam question, okay? So that's it for the difference between read replicas and multi-AZ, but you need to absolutely understand this going into the exam because a lot of questions will go and be about it. So a question that can come up in the exam is around how do we make an RDS database go from single AZ to multi-AZ. So what you should know is that it is a zero downtime operation. That means you do not need to stop the database to go from single AZ to multi-AZ. The only thing you need to do is to click on modify for the database and enable multi-AZ. That means that your RDS database instance is going to be you doing, it will be a snap between the two databases, and so therefore this tenant database will catch up to the main RDS database. And there you go, you will be in a multi-AZ setup. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's go ahead and create our first Amazon RDS database instance. So on databases on the left-hand side, you can just click on Create Database. Okay, so when we are on the screen, we have to select the database engine. So we have 6 engines types, and we have 2 database creation methods, would be standard create or easy create. Because I want to show you all the options, we're going to choose standard create, which is going to be longer, but we'll show you all you need to know for the exam. Now for the engine options, we have Aurora that we'll deal with later on, MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server. For simplicity's sake, right now I'm just going to use MySQL and go down with it. So we're going to use the version that is provided right here, MySQL 8.28, but whatever is the first selected is good enough for you. Next, we have
If you find yourself about what exactly I'm talking about, and then I have the source for the idea. I talk about how a lot of frameworks, 10 books, right? I focus on a number.
Good evening. Anything else? You're actually, because my fleeting ones are going to become permanent. The whole idea is cast and I rename, so you.
To me, there are two things who Lumen and other creative people have proved that it works. When people first hear current date, time, title of the activity on the list. That way, single nodes can function as tags, and these non-existent ghost nodes will be displayed on the graph view. Pressing Ctrl Command G will show you the graph of the
have templates to meet our use case. So if you wanted to have a free tier setup, you would click here and this would pre-select some options for the free tiers. Or if you had a dev test environment, then this would pre-select options for dev test. And production, you have full control over every option. Now I'm going to use production as a template, but we'll modify every option to be within the free tier. But I'm showing you this so that we can have a look at all the options one by one. So first, for availability and durability, we have three options. We have single DB instance, multi-AZ, or multi-AZ DB cluster. So because we want to remain within the free tier, we're going to use single DB instance. But if you want to have a standby database instance, you would use a multi-AZ type of option. Now for the DB identifier, we're going to use database 1. The credential is admin, and the password, I'm going to use a password here that I'm just going to enter as we go. Okay. Next, for the instance configuration, this is the size of the underlying EC2 instance. So in our case, we can have standard classes, memory optimized classes, or burstable classes, and you can choose whatever instance you want amongst each class. But to remain within the free tier, we're going to use burstable classes, and we're going to choose dbt3.micro. Now for storage type, if you are in production, you're going to use an IO1 type of EBS volume, but as we ran within the free tier, I want to use a GP2 type of volume, which is lower performance, and we'll use maybe 20 gigabytes of allocated storage. Now we can also enable storage autoscaling, which will automatically increase the size of the EBS volume in case we are starting to near a threshold. And what is the maximum amount of storage we want in case we enable autoscaling? Let's say 1000 gigabytes. Now for connectivity, we have the option to connect with what's called an EC2 compute resource. So this is in case you wanted to make sure that there is connectivity between a specified EC2 instance and your RDS database. You would just choose it in this list, and then the configuration in terms of networking would be done automatically. So you don't have to handle security groups, etc., which is very helpful when you're a beginner. But we're going to look at all the options. So I'm going to say don't connect to an EC2 compute resource. Therefore, we have to deploy in a specified VPC. And then we have to specify a subnet group, and then whether or not we want public access to the database. So I'm going to say yes, because I want to access this database from my own computer. Next, we need to choose or to create a security group. So I'm going to create a new security group, and the name is going to be demo database MySQL. In terms of AZ preference, we could set one, but no need. And as you can see, the port to connect to the database on MySQL is 3306. In terms of database authentication, we have three mechanisms. The first one is to use a username and password. This is what we'll be using. But we can also enable IAM database authentication to have IAM users and roles directly access RDS, or we can enable Kerberos. But right now, I'm going to leave it as password authentication. We can enable monitoring, and enhanced monitoring gives you a 60-second granularity on your resources, but I can disable it right now. And we can specify some additional database configuration. So for the initial database name, I'm just going to enter mydb. Then we can enable or disable backups. So backups are automated, and we can have a backup retention period of 1 to 35 days. And if I said 0, then it will just completely disable them. So let's leave it at 7. And then for backup window, we can choose a specific time window where the backups will be done, or no preference. Then we can export the logs into CloudWatch logs. For example, you can export the audit log from RDS into CloudWatch logs for long-term retention. Then, do we want to have a maintenance window for the minor version upgrades? And if so, what is a window you want to have? And do you want to have deletion protection? Is this to protect the database from being accidentally deleted? Okay, so now as you can see, we have some DB cost of $17 per month, even though I told you this is within the free tier. So it's not reflected right here. But if you use a dbt2 micro type, then you will have a free tier for this, even though it says here $17.34 US. So when you're done, just create this database. So while my database is being created, let's go ahead and download SQL Electron. And this is a SQL client that we're going to use to connect to our database. So very simple, you're going to click on Download GUI and then click on it. Take the latest version for whatever platform you have. So you have latest Windows, and then for Mac it's going to be a DMG. So I'm going to do this one, then open it and install it. Okay, so my database is now created. It took a little bit of time, and now as you can see, it is available. And so what I'm going to show you are a few options. So first of all, we have the endpoint right here and the port 3306, and it's linked to this security group. And this security group, if we click on it and look at the inbound rules, we can see that we have an inbound rule here on TCP port 3306. So that's great, okay? Coming from just my IP address. Okay. So you should, of course, modify this security group if you have problem connecting to your database instance to maybe have it to anywhere IPv4. Okay, so now let's take this endpoint and we're going to connect to it using SQL Electron. So using SQL Electron, I'm going to add a new database. I'll call it RDS demo. It's a database of type MySQL. And then for the server address, I'm going to enter what I have right here on port 3306. The user is admin and the password for me was password. And then the initial database is MyDB, as I entered it from before. Let's click on tests, and the connection is successful. If it's not successful, please have a look whether or not your database was set to be a public database, number one, and number two, have a look at your security group settings to make sure that your IP is allowed in. So let's save this and connect to our database. And now I'm connected into my database, directly into MyDB, which was the database that was created. And in here, I could go ahead and enter some create table statements. So create table, my table, and then just a name of varchar 20 and a first name of varchar 20. So it's just a very quick statement just to show you how SQL works, but this is definitely out of scope for the exam. Execute this. So now we have my table that has been created, and then we don't have any content in it, okay? But you could have an insert statement to insert some data into your table. So you would say, for example, enter the value Marek, and then the value here, Stefan. Execute this. And then if you click on select rows, then you see that my table has my name and my first name to be Marek and Stefan. So this is how you would use a RDS database with MySQL. But again, out of scope of the exam, I just want to show you the full picture of using SQL Electron. So back in here, my RDS database is fully managed. So this is great. We can use it. This is amazing. Other things we can do that are worthy are to create a read replica directly from this database. So we can create a read replica. And then this read replica would allow us to have more read capacity for our database, which would be very, very helpful. And do we want whether or not that database to be multi-AZ for recovery purposes? So I'll keep it as no and cancel it. Next, we can have a look at monitoring. And monitoring, for example, could show us the CPU utilization. And as we can see, well, the CPU utilization is monitored by my database, and we can monitor this, for example, for scaling our database if in case we have too many connections into it. We can have a look at the database connection count as well to see how many clients are connected into our database, and a lot of metrics overall, okay? Other things you can do with RDS is around creating snapshots. So you can take a snapshot, and this will snapshot your database, and you can restore it wherever you want. You can restore to a point in time for your database, or you can even migrate a snapshot if you wanted to migrate a snapshot into a different region, for example. So all these are a bunch of options that we can use. But as we can see, the whole power of RDS is to manage the database for us, to have read replicas, multi-AZ, we can increase the instance type as we go along and so on. And that's all comes very handy from a managed service perspective. So you've seen all you need to know for your RDS database. I hope you liked it. And just to finish this off, please make sure to delete the database. So to delete it, first you need to remove the termination protection. So you go to modify, and then at the very bottom, you will scroll down and find the delete protection settings. So here it is. We'll disable it, press on continue, and then apply immediately. And then once the delete protection is done, you can go ahead and delete this database. You can remove creating a final snapshot and then say delete me and acknowledge the fact that upon deletion. So now let's do a short lecture on RDS custom. So we know that with RDS, we don't have access to any underlying operating system or customization, but with RDS custom, we actually do. And RDS custom is for two database types. It's for Oracle and Microsoft SQL Server, in which, thanks to RDS custom, we have access to the OS and database customization. So with RDS, we still get all the benefits of automated setup, operations, and scaling of the database in AWS. But with the RDS custom option, the custom part of RDS custom, we actually have access to the underlying database and operating system. So we can actually configure internal settings, install patches, enable native features, and we can actually access the underlying EC2 instance behind RDS using SSH or SSM Session Manager. So here is my EC2 instance. And as a user, we can now, if it's using Amazon RDS Custom, apply customizations and SSH into it. To perform any customization, it is recommended to deactivate the automation mode so that RDS does not perform any automation or maintenance or scaling or whatever you want while you perform your customization. And also, because you may actually break things because now you have access to the underlying EC2 instance, it is much better to take a database snapshot, otherwise you will not be able to recover from your actions. So to summarize, RDS versus RDS Custom, RDS will manage your entire database and your operating system. Everything is managed by AWS, you don't have to do anything. And RDS Custom, it's for Oracle and Microsoft SQL Server only, and you have actually full admin access to the underlying operating system and the database. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So let's talk about Amazon Aurora because the exam is starting to ask you a lot of questions about it. Now, you don't need deep knowledge on it, but you need enough high-level overview to understand exactly how it works. So this is what I'm going to give you in this lecture. Aurora is going to be a proprietary technology from AWS. It's not open sourced, but they made it so it's going to be compatible with Postgres and MySQL. And basically your Aurora database will have compatible drivers. That means that if you connect as if you were connecting to a Postgres or a MySQL database, then it will work. Aurora is very special, and I won't go too deep into the internals, but they made it cloud optimized, and by doing a lot of optimization and smart stuff, basically they get 5x performance improvements over MySQL on RDS or 3x the performance of Postgres on RDS. Not just that, but in many different ways, they also get more performance improvements. To me, I've watched it, it's really, really smart, but I won't go into the details of it. Now, Aurora storage automatically grows, and I think this is one of the main features that is quite awesome. You start at 10 gigabytes, but as you put more data into your database, it grows automatically up to 128 terabytes. Again, this has to do with how they design it, but the awesome thing is that now as a DB or a sysops, you don't need to worry about monitoring your disk. You just know it will grow automatically with time. Aurora can have up to 15 read replicas, and the replication process is going to be faster than MySQL. You will see sub 10 millisecond replica lag typically. Now, if you do failover in Aurora, it was going to be instantaneous. So it's going to be much faster than a failover from multi-AZ on MySQL or RDS. And because it's cloud native, by default, you get high availability. Now, although the cost is a little bit more than RDS, about 20% more, it is so much more efficient that at scale, it makes a lot more sense for savings. So let's talk about the aspect that are super important, which is high availability and read scaling. So Aurora is special because it's going to store 6 copies of your data anytime you write anything across 3 AZ. And so Aurora is made such as it's available, so it only needs 4 copy out of 6 for writes. So that means that if one AZ is down, you're fine. And it only needs to have 3 copy out of 6 needed for reads. So again, that means that it's highly available for reads. There is some kind of self-healing process that happens, which is quite cool, which is that if some data is corrupted or bad, then it does self-healing with peer-to-peer replication in the backend, and it's quite cool. And you don't rely on just one volume, you rely on hundreds of volumes. Again, not something for you to manage, it happens in the backend, but that means that you just reduce the risk by so much. So if you look at it from a diagram perspective, you have 3 AZ, and you have a shared storage volume, but it's a logical volume, and it does replication, self-healing, and auto-expanding, which is a lot of features. So if you were to write some data, maybe blue data, you'll see 6 copy of it in 3 different AZ. Then if you write some orange data, again 6 copy of it in different AZ. And then as you write more and more data, it's basically going to go, again, 6 copy of it in 3 different AZ. The cool thing is that it goes on different volumes and it's striped and it works really, really well. Now we need to know about storage, and that's it. But you don't actually interface with the storage. It's just a design that Amazon made, and I want to give it to you as well so you understand what Aurora takes. Now Aurora is like multi-AZ for RDS. Basically there's only one instance that takes writes. So there is a master in Aurora, and that's where we'll take writes. And then if the master doesn't work, the failover will happen in less than 30 seconds on average. So it's really, really quick failover. And on top of the master, you can have up to 15 read replicas, all serving reads. So you can have a lot of them, and this is how you scale your read workload. And so any of these read replicas can become the master in case the master fails. So it's quite different from how RDS works, but by default, you only have one master. The cool thing about these read replicas is that it supports cross-region replication. So if you look at Aurora on the right-hand side of the diagram, this is what you should remember. One master, multiple read replicas, and the storage is going to be replicated, self-healing, auto-expanding, little blocks by little blocks. Now let's have a look at how Aurora is as a cluster. So this is more around how Aurora works. When you have clients, how do you interface with all these instances? So as we said, we have a shared storage volume, which is auto-expanding from 10 gigabytes to 128 gigabytes. Your master is the only thing that will write to your storage. And because the master can change and fail over, what Aurora provides you is what's called a writer endpoint. So it's a DNS name, a writer endpoint, and it's always pointing to the master. So even if the master fails over, your client still talks to the writer endpoint and is automatically redirected to the right instance. Now, as I said before, you also have a lot of read replicas. What I didn't say is that they can have auto-scaling on top of these read replicas. So you can have 1 up to 15 read replicas, and you can set up auto-scaling such as you always have the right number of read replicas. Now, because you have auto-scaling, it can be really, really hard for your applications to keep track of where are your read replicas. replicas, what's the URL, how do I connect to them? So for it, you have to remember this absolutely for going for the exam. There is something called a reader endpoint. And a reader endpoint has the exact same feature as a writer endpoint. It helps with connection load balancing, and it connects automatically to all the read replicas. So anytime the client connects to the reader endpoint, it will get connected to one of the read replicas, and there will be load balancing done this way. Make sure, just notice that the load balancing happens at the connection level, not the statement level. So this is how it works for Aura. Remember, writer endpoint, reader endpoint. Remember auto scaling. Remember shared storage volume that auto expands. Remember this diagram, because once you get it, you'll understand how Aurora works. Now, if we go deep into the feature, you get a lot of things I already told you: automatic failover, backup and recovery, isolation and security, industry compliance, push button scaling by auto scaling, automated patching with zero downtime, so it's kind of cool dark magic they do in the backend. Advanced monitoring, routine maintenance, so all these things are handled for you. And you also get this feature called backtrack, which is giving you the ability to restore data at any point of time. And it actually doesn't rely on backups, it relies on something different. But you can always say, I want to go back to yesterday at 4 p.m. And you say, oh no, actually I wanted to do yesterday at 5 p.m. And it will work as well, which is super, super neat. So that's it for Aurora, and I will see you in the next lecture. So let's go ahead and create an Amazon Aura database. Now, just so you know, if you follow along with me with this hands-on, this is going to cost you a bit of money. The most important thing for you is to just follow the instructions and to see what the options are, but you don't need to actually go ahead and create the database if you don't have some money to spare for it. So we're going to choose a standard create. And as you can see, we have two different options for Aura. We have the MySQL compatible option and the PostgreSQL compatible option. For this hands-on, I'm going to use MySQL. I will scroll down, and here you have to choose a version. So you have a version selector right here, and you can have filters, for example, to only show the versions that support the global database feature, or the ones that support the parallel query feature, or the ones that support serverless v2 feature. So what I'm going to do is I'm going to keep the default version as proposed by the Aura console, which is 3.04.1, but this may be a different version for you. Next, I will choose a template, and basically choosing production allows me to configure everything. So this is what we want to do. We'll choose production. For the DB cluster identifier in RDS, we'll choose database 2. We have the master username being admin, and then you can enter a password, which I will right now. Okay. Then for cluster storage configuration, you have two options. You can have Aura standard or IO optimized. So if you have high input and output operations, read and write operations on your Aura database, you may want the IO optimized. But for cost-effective workloads that don't use Aura too much, then you may want to use Aura standard. Now for instance configuration, you have the possibility of choosing the class of instance you want for your database. So you can see you have different ones that can be memory optimized. You have the burstable classes, and you can choose to include the previous generation classes. It works sometimes, but for now, I'll just use DBT3 medium. And also, if you use a version that is compatible with serverless, you will see the serverless v2 option here. And in here, you don't select the instance type. You just select what's called in Aura capacity units, ACU, and you say what is the minimum ACU you want and the maximum ACU you want, and this will allow your database to scale between these two capacity units automatically. So for now, I'm going to use burstable classes of DBT3 medium. Now for availability and durability, we have the option to have Aura replicas. So here we create an Aura replica and a reader node in a different AZ, which is going to give us availability, enhanced availability, as well as better reads across AZ and fast failovers. So this will cost more money, but at least I can show you the full power of Aura. Next, for compute resource, we are not going to connect to an EC2 resource. We're going to choose a network type of IPv4. This is going to be enough for our needs. But if you have IPv6 as well in your VPC, you can use dual stack mode. Then you are going to be in the VPC that is the default VPC. With the default subnet group, I will, yes, allow public access to allow each of us access to the Aura database from a public IP. And for VPC security group, I'm going to create a new one, and I will call it demo database Aurora, which will allow us to connect to our Aurora database. Next, for additional configuration, we can see that the database port is 3306, which is the MySQL port if you selected MySQL before. So we have the option to also have local write forwarding. In case the writes are applied to the read replica, then they will be forwarded automatically to the write instance. This is allowing you to have an easier connection management. Now we can also have database authentication to use IAM-based database authentication or Kerberos-based to basically authenticate your user using an external mechanism. We have enhanced monitoring. I can disable it because we don't need it. And we have additional options for your database. For example, the initial database name is going to be MyDB. And then backup retention is going to be 1 day. This is great. We can have encryption for our database. We have several options around backtracking to rewind our database and log exports, but I will not go over them. We have deletion protection to protect the database from being accidentally deleted. But everything looks fine now. And as you can see, we have some monthly costs. So make sure that you are aware of this by creating this Aurora database. So let's go ahead. And create this database instance to write and to read. To connect, we have two endpoints. We have a reader instance, a writer instance, and have also a dedicated endpoint. And that instance over here would also have a dedicated endpoint once it is being created. So it's still being in the creating space. Okay, so we have these features that are cool. Then we have other features. So we can add more readers into our reader cluster to add on with scaling capacity. And we can also create a cross-region read replica if you want to have a replica in another region. The average number of connections to your Aurora replica, then scale your read replica. So it's a read replica scaling policy. And say, okay, I want to make sure that my read replica stay at the target value of 60%. And if I go over, please create more read replica. We could also define a scaling period for the scaling policy, which makes sense. And what's the min and the max capacity? So 1 replica up to 15 Aurora replicas. And this is very handy to have read replica auto scaling as a database. So I cancel it. We don't need it right now. And now I've made sure that both my my database and endpoints are available. So we're good to go. So one last thing I can do to show you the whole power of Aurora is to do action and add AWS region. And this is only possible if you chose a version of Aurora that was enabled with the global database feature. But here we can add the database region to other regions, and this will allow you to get a global Aurora. Now, as you can see, this is not possible with this cluster because we need to have an instance with a compatible size to do this first. So we need to change the instance, for example, to a large type of instance, and then we would be able to add other regions to the database cluster. But anyway, I wanted to show you the feature right here. Okay, so that's it for Aura. This is pretty much what you get, which is an amazing database with amazing performance, great scaling capacity, global, and so on, serverless. So really, really complete database. I really like this offering from AWS. Now, to be done with this hands-on, just take this database and you want to delete it, but as you can see, it's not available. So what you need to do first is to delete the reader instance. So type it, delete me. Then you need to delete the writer instance. So again, action, delete, and then you type delete me. And then once both these things are deleted, you are going to be able to delete your whole cluster. So I will wait when it's done. That's it. My database is now deleted, and I will see you in the next lecture. Let's talk about Elasticache security. So Elasticache supports